Hello class, I hope all is going well for you. This is the second curriculum review lesson that I put out, and this one is over inequalities. So I hope you did yesterday's, which was over equations, because that will kind of feed right into today's lesson. So let's begin. So what is the difference between an equation and an inequality? Well, the first thing is that an equation has an equal sign, where an inequality is going to have one of these signs. You've got less than or equal to, greater than or equal to, or not equal. And all of those constitute our inequalities, because inequality means something that's not equal. The second thing that's different is that an equation has only one solution, whereas an inequality has many solutions. Okay, so the next question that you should ask yourself is, do you solve an inequality differently than an equation? And the answer is, no, you don't. You solve it exactly the same. There's just one minor difference, and we'll talk about that in just a second. So what are the steps then? Okay, well, as we talked yesterday, the steps to solving an equation or an inequality, the first step is always get your letters on one side of the inequality, or the equal sign, for equations. And this one, it's the inequality. How do I do that? Well, just like with equations, we add the opposite. Step number 2 is get your number on the other side of the inequality. And again, how do I do that? I add the opposite. So both of those two steps are exactly the same as equations, not anything different. The only thing I could throw in that might be different would be parentheses, where you have to use the distributive property first before you start moving things around. Okay. Step number 3, this one's the big one. You solve, and this is where you do the opposite, where you're left with either a multiply or a divide statement. Now the one thing you have to remember is that if your coefficient, the number that's with your letter, is negative, you're going to flip the inequality at the end. Okay, so let's see if we can do a couple of these. Okay, so here's our first inequality. 3x minus 5 is greater than 10. Now in most of the inequality problems that I'm going to give you, we're going to have to graph the solution, because this is where we've got to either do the open circle or the closed circle, okay, and then we shade to the left or to the right. Okay, so first thing I'm going to do on this particular problem is I'm going to change this subtraction sign. So I'm going to change subtraction to addition, next number to its opposite. Now I need to get rid of this negative 5, because you'll notice my letters are already together on the left, so I need to move my numbers over on the right. Right? So to do that, I add its opposite. So we can do that several ways. The first way we're going to do it's the old way, kind of the mathematically correct way, or the long way. 3x plus negative 5, and to get rid of that, I'm going to add a positive 5. Is greater than 10, and if I add that to one side, this 5, I must add it to the other side as well. So I add a 5 here. So my 5's then cancel each other out, and we're left with 3x is greater than, and then 10 plus 5 gives you 15. Now to get rid of this multiply by 3, I'm going to divide by 3. Now here's where we have our issue. If this number is positive, then nothing's going to happen to the inequality. If this number were negative and I divide through by a negative, it kind of acts like a hook and it flips this negative whenever you do it. Okay, and this one it's positive, so we don't have to worry about it. So I divide this side by 3 as well, and I end up with x is greater than, and 15 divided by 3 is 5. Okay, so now we have to graph this. Now this kind of an inequality, whether it's less than or greater than, it's going to give you an open circle because it doesn't include 5. It's everything that's greater than 5. So that's going to give me a open circle on 5, and I'm going to shade to the right, because the values that are to the right of 5 are going to make this a true statement. So if I were to take the number 10 and plug it back in up here, okay, I would do 3 times 10 is 30. 30 minus 5 or plus negative 5 would give me 25. Is 25 greater than 10? And yes, it is. So any value that's greater than 5 will make this a true statement. And that's what an inequality is all about. Finding what number will make that a true statement. Okay, or what side of the values. So let's try another one. Okay, this one's going to be a little bit tougher. Okay, because one, my x's are over here on the right hand side, and we normally don't like that. Okay, so one thing you could do if you wanted to is you could flip this. Okay, I'm going to work it as it is, but I could take this negative 4x plus 24 and put it over here on this side, and the 12 over on this side. But the one thing you have to be real careful of when you flip that is make sure the inequality is still pointing the right direction. This one's pointing to 12, so it's got to be pointing to 12 when you flip it as well. Okay, so again, my letters are already together, so I don't have to do anything with those. I just need to move this 24 over to be with the 12. Okay, so I'm going to do that. So I do that. Now this one I'm going to do it the new way, the shortcut way. You remember on this one, the first problem, I added it within the same line. Shortcut, I'm just going to add, I've got a plus 24, so I'm going to do a minus 24 to get rid of it. And I do a minus 24 over on the other side as well. So we end up with 12 take away 24 gives us negative 12 is less than or equal to negative 4x, because our 24s cancel each other out. Now how do I get rid of this? Multiply by negative 4. I do a divide by negative 4. And if I divide this side by negative 4, I got to divide the other side by negative 4 as well. Now if this number right here is negative, my inequality is going to flip. So my 4's divide out and I get positive x. My inequality right now is pointing to the negative 12, so I need it to point back to the x now. Okay, and then negative 12 divided by negative 4 gives us 3. So this is 3 is greater than or equal to x, or x is less than or equal to 3. Now if I were to plug any value that is less than or equal to 3 into this particular inequality statement, it will give me a true answer. Okay, so if I were to plug in, one of my favorite values is 0. 0 is less than or equal to 3. If I were to plug 0 in, negative 4 times 0 is 0, plus 24 is 12, less than or equal to 24. And yes, it is. Now, because this is a less than or equal to sign, that means it's going to be a closed circle on 3, and I'm going to shade to the left. So all values that are less than or equal to 3 will make this a true statement. Okay. Now, what if I did have one that had parentheses in it? Do we do it any differently? No, it's just we've got to use the distributive property, to start off with. So I need to distribute this 2 to each member of the parentheses here. So 2 times negative 2x gives me negative 4x, plus 2 times 4 gives me 8, is less than, and I have to do the same thing with this 2. 2 times x is 2x, plus 2 times 3 is 6. And now we go through our steps. Get our letters on one side, get our numbers on the other. So I'm going to take this 2x, move it over to be with a 4x. So minus 2x, minus 2x. So that gives me negative 6x plus 8 is less than 6. Now I need to move this 8 over to be with the 6. So I add a negative 8 to both sides because I had a plus 8. Oh, what happened there? Okay, try that again. I'm working on my slate, so it makes it a little different. Okay, so now my 8's cancel out, and I'm left with negative 6x is less than, and then 6 plus negative 8 gives me a negative 2. Okay, so now I got to divide by negative 6, divide by negative 6. Now, since I'm dividing by a negative number, my inequality is going to flip. So x is not less than, but x is now greater than, and now negative 2 divided by negative 6. Well, because this 2 it's truly greater, but in a fraction sense it is less than the 6, all we do is we simplify our fraction. The negative and negative will turn to positive, and then the 2 over 6 simplifies down to 1/3. Now if you were to do that on the calculator, you would get a repeating decimal, so you'd have to change it back to the fraction. Okay? Now, what if we had a word problem and I asked you to interpret the word problem? Okay, so in this one right here, I want you to write an inequality and solve it. So it says, Benjamin wants to go fishing on the lake. A boat rents for $12 per hour, and a rod and reel rent for $20 per day. If he wants to spend no more than $80, how many hours can he spend fishing in the boat? Okay, so we look up here and it says, a boat rents for $12 per hour. We just don't know how many hours, so we know that our variable is going to go with the 12. So 12x, or we could do h. Okay, and I'm going to be adding to that a rental for a rod and reel, which is $20 per day. So that's just a straight 20. Now it says he wants to spend no more than $80. Okay, no more than means that this value here must be less than or equal to 80. So no more than is a word that means less than or equal to $80. So there's the inequality that we would use in order to answer this question. So now we solve it. Okay, our letters are together on one side, so I need to move the 20 over to be with the 80. So minus 20 minus 20, and I end up with 12x is less than or equal to 60. Okay. My number here with my letter is positive, so I don't have to worry about flipping my sign. Okay, so I divide by 12, I divide by 12, so x is going to be less than or equal to 5. And that 5 represents Go back in the equation. It says how many hours can he spend fishing in the boat? No more than 5 hours. And that would be for a cost of $80. Okay, so that's my review for inequalities. Just remember that we solve inequalities exactly the same way that we solve equations. Okay, get your letters on one side, get your numbers on the other side, and then solve. The one thing you got to remember is that if your number with your coefficient is negative, your inequality is going to flip. So what I'd like for you to do for your assignment is I want you to solve this problem. Okay, once you've done so, go to the following link or go to Google Classroom, okay, or type in that link and answer this question, fill out the form. This question says, Deanna is inviting 10 friends to a party. If she wants to spend no more than $120 on her guests, and dinner for each guest costs $8, what is the most she can spend on party favors for each person?